All right, guys, it's Mrs. Cameron here. I just want us to continue rolling along through our CLT practice test number 2. We left off at question number 111, which says, in the circle below, C is the center and points A and B lie on the circle. AC is 3 centimeters. And AB is 3 square root of 2. What is the length of the minor arc AB? So from here to here. So if we know what degree our angle C is here, if we find this out, then we can use the circumference of our circle and find out what portion of the circle our minor arc is here. So if you take a look at the reference sheet, you can see something similar to this square root of 2. And now I also know that from C to A is a radius, and from C to B is also a radius. So that means we have an isosceles triangle, and that this side over here, since it's a radius, is also 3. And if we look at this, 3, 3 square, and then 3 square root of 2 as our ratio of our sides, and you look at the reference sheet, I do have it on this reference sheet, that you're given 2 sets of special ratios, and one of them is 1 to square root of 2. Okay, and it says that this is the very bottom of the reference sheet. You can see 1 to square root of 2 is a special right triangle. It is a 45, 45, 90 triangle. So if our angles are 45, 45, and 90 degrees, then we can find out this arc here. And you see this 3 to 3 square root of 2, and our 1 to square root of 2. These ratios are the same just from here to here. Everything got divided by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. 3 square root of 2 divided by 3 is a square root of 2. So we have just proved that our angle C here is 90 degrees. So I'm going to draw my little right angle symbol. And since a circle all the way around is 360 degrees, 90 degrees is how much out of 360 degrees? It'd be 90, 90, 90, 90. It's 1/4. There's a few ways you could prove that, but it is 1/4. So now, knowing that the circumference of the whole entire circle is 2 pi r, where our radius is 3, our circumference is 2 pi times 3. 2 times 3 is 6 pi. The radius of our minor arc AB, we're going to multiply times 1/4, or just divide by 4. So 6 pi over 4. And 6 and 4 can both be divided by 2, which leads us to...
Please excuse the interruption. The CPE department
6 divided by 2, 3 pi over 4 divided by 2, 2, and we have found our answer for question number 111. So we can move on to question 112. Sorry about that. Number 112 says the circumference of circle A is approximately 31 inches. Circle B has a radius of 8 inches. Circle C has a diameter twice the length of circle B's circumference. Which of the following ranks the area of the circles from least to greatest? So, okay, the circumference of A is approximately 31 inches. Circle B, 31 inches. Circle B circumference would be 2 pi r, where the radius is 8.
Teacher, you are in campus O'Neill.
Would be about 2 times 8 is 16 pi, and 16 times pi, pi is about 3.14, or even just about 3. If we're just estimating, right? We'll just round it to the whole number. 16 times 3, 16, 32, 48. So the circumference would be about 48 inches. And then circle C has a diameter twice the length of circle B's circumference. So if the diameter is bigger than circle B, then the circumference, if we're comparing circumferences, would be 2 times pi, and the diameter, if the diameter is twice the size of circle B's circumference, then the radius would be about 48. So if we multiply that, it'd be huge. So they're already in order. A is the least, 31 is less than 48, and 48 is less than whatever you would get when you multiply all of this. So number 112, the answer is A. And just to be a completionist here, 2 times 48 would be 96 pi. And then if we're multiplying, if we're using just 3 for pi for a rough estimate, 96 times 3, 288. It'd be 288 inches. So already in order. Number 113 says, a biologist is studying a flattened circular cell on a slide under a microscope. He determines that the cell has a radius of 8 nanometers and also observes that an arc corresponding to an angle of about 60 degrees on the cell is studded with proteins. About how long is the portion of the cell wall that is not studded with proteins? So I'm going to look at a circle and say, okay, a 60-degree angle, go into the center-ish, right? If this is 60 degrees, the radius is 8. This is studded with proteins. And we want to find out what is the length of the cell wall that is not. So we want to find the length of this right here. And so this section of the circle, right, if You have a 60-degree angle. How many 60-degree angles could you fit inside of a circle? I'd say, well, 6 times how much equals 360? And that would be 6 times 6. So this is the area width is 1/6, and the area for our circumference without the proteins is 5/6 of our circle. So if we find the circumference of our circle using our radius, so circumference of the whole circle would be 2 pi r from the reference sheet. And we already know that the radius is 8. So I'm going to erase the r and put an 8. And I only want the area that is not studded with proteins. So that's 5/6 of this. So I'm going to take my answer from this and multiply it times 5/6. So I've got, really, I can just put everything on top. 5 times 2 times 8 pi over 6. And they're not doing anything with the pi, so I don't need to round it. 5 times 2 is 10 times 8 is 80 pi over 6. And both of those are even numbers, so I can take the top and bottom both and divide them by 2. So 80 divided by 2, 6 divided by 2. And that'll give me 40 pi and 6 divided by 2 over 3. So answer choice C is the correct answer for question 113. And okay, well, looks like I'm out of time on this video, so I will catch you on the next one.